Inside of this box right here is our latest revision for Openviro, both the brains and the sensor boards. Both of them are fairly minor revisions, but a major step toward being able to actually ship a final product. So, let's dive in. Welcome back to Craft Computing, everyone. As always, I'm Jeff. So, like I said, today I wanted to show off some of the latest revision PCBs that we just got back for Openviro Axe PoE, go over some of your questions about the project in general, take a look at the new case design for the temperature probes, and take a quick look at the firmware. Let's go ahead and start off with the PCBs. The brain looks pretty much identical to the last version of the board, although there are a couple notable changes. For starters, the last PCB had a routed gap around the power circuitry. That was actually a leftover design feature when we were working on integrating a temperature sensor directly onto the brain PCB. Unfortunately, when stepping down 54 volt power over Ethernet to either 5 or 3.3 volt, which is what the Axe PoE runs off of, the unwanted byproduct of that conversion is heat. In fact, here is our very early prototype. You can tell because it's red. We mounted a temperature sensor right here on the front of the unit, but we wound up needing to remove the temperature sensor entirely as we were seeing nearly 6-degree deltas between the internal and external temperature probes. And on a product that's designed to be an accurate temperature sensor first and foremost, that just wasn't acceptable. I actually like the change more than our original idea of integrating a sensor directly onto the PCB, as now you can place the controller anywhere you need in the rack and put the temperature sensor where they make the most sense. So here is the new PCB design. You can see we no longer have that routed channel around the power circuitry. We also added overcurrent and short circuit protection on both of the sensor ports, which should alleviate any issues from users connecting incompatible cables or accidentally plugging into a phone outlet. We don't want to release any magic smoke because of user errors. The bigger change, though, is to the THP sensors themselves. Here is our old version, and here is the new one. You can see it's quite a bit smaller. The new version inside of the case measures just 34 by 40 millimeters wide and 16 millimeters tall, so you should have no trouble putting the sensor basically anywhere you need inside of a server rack. We've also been working on integrating a pair of magnets into the base of the 3D printed case, but I'm actually not entirely sure that this will make it into the final product. I'm having trouble sourcing magnets that are both strong enough to hold the sensor and the weight of the cable to the server rack, while also being small enough to fit inside of the sensor enclosure. But that's what rack screws are for, right? In the most recent design, I've added a rack screw hole to the side of the sensor enclosure. And overall, I like the idea of using rack screws more than I do relying on magnets. While magnets, in theory, should hold the case against any piece of metal, because the cases are made out of PETG, they don't have much friction to them and tend to slide around with even the slightest amount of weight on them, including the weight of the cable that you need to connect it to the brain. Right now, my gut is actually telling me to eliminate the complexity and variables of using magnets inside the case and just go with rack screws. I will also note both the brain and the temperature probes are compatible with rack studs, as I wanted a nice and easy mounting solution for these if you want to go that route. So, regardless of whether or not there are magnets embedded in the bottom of the case, we will be rack stud compatible. Besides the form factor, there were two main changes we made to the initial run of probes. First off, we made a mistake in laying out this PCB, where we flipped two of the pins that are needed to connect the temperature sensor to the brains, which means I had to custom crimp cables that matched the accidental pin layout, which, as you can imagine, wasn't all that fun. But with that bug fixed, off-the-shelf 6P6C cables now work as they should between the brain and the THP probes. Secondly, we added a power LED to the probes. Now, this was a feature that was requested quite a few times in the launch video, so I thought we could give it a go. Right now, we're testing to see if there's any impact on the temperature readings because of the increased power draw. Even with some baffling between the regulator, the LED, and the temperature sensor itself, we are seeing about a 1 to 1.5 degrees Celsius increase in temperature readings versus running the temperature sensors without an LED. We're going to experiment with some different LEDs and resistor values to see if that's a feature that we can keep, but anything that impacts temperature accuracy will obviously need to be addressed. So I don't know if the LED will make it to the final revision of the temperature probes. I'm really happy with the overall design of the temperature probe enclosure as well. So obviously we have the main body right here. The temperature probe drops in on top of that. We have a little bit of baffling and an enclosure around the LED that also holds the screws in the proper standoff. That drops right in on top. And finally, the top shell, which is a translucent green. I really like the overall design. It's easy to put together, it's repeatable, and I think it looks pretty nice. Next, let's take a look at the current firmware, including what setting one of these up in your rack is going to look like. As I mentioned in the launch video, we're trying to make this a smart device that's also as dumb as possible on purpose. There's no SSH, there's no web portal, there's no cloud connection service that you need to worry about securing inside of your environment. Openviro is configured over a direct serial connection, and the only services running on it are SNMP. It's your device and your data, and that's the way it should always be. To get started, you'll want to make sure that the Openviro Axe is running the latest version of firmware, which you can download directly from our GitHub page. To update the firmware, make sure you're holding down the boot button right here on the front of the device, and connect a USB-C cable from your computer directly into the front right here. When the device is in flash mode, it will appear as a USB drive on your PC. Simply drag and drop the latest firmware onto it, it will automatically reboot and boot into that latest firmware. After that, you'll use the exact same USB-C cable to connect via a direct serial connection. You can use a serial terminal like PuTTY or pretty much any other console emulator that you'd like to use. Once connected, you'll be greeted by the main menu. Pressing I will take you to the info screen, which is a read-only menu to view the current configurations. Things like current IP address, device name, SNMP configuration, as well as the current readout from both the front and rear sensors. Going back to the main menu and pressing C will get you to the configuration screen, which allows you to modify any of those settings. We have options in place for both dynamic and manual configurations for pretty much every setting. You can choose DHCP or manual IP addresses, DNS servers, or NTP servers. Just below the network settings, you'll find the SNMP configuration. Now, Openviro runs in SNMP v2c mode by default, but in our current version, we have officially added SNMP v3 support, which allows for encrypted SNMP requests and is a requirement for many enterprise networks. This is a huge step in making sure we're supplying not only an accurate temperature sensor, but a much more secure device as well. And before I wrap up today, I wanted to answer some of the most asked questions about the Openviro Axe PoE, starting with, why did we use RJ12 instead of RJ45 for the sensors? There's a couple reasons for that actually. First off is ease of use. While I know there's not a single IT worker on this planet who would ever make this mistake, we wanted different plug types for different ports. We have both Ethernet and temperature sensors on this unit, and we wanted to avoid users plugging in the wrong cable to the wrong ports. Secondly is actually cost, as an RJ45 jack is significantly more expensive per board, both in BOM costs and for the final assembly. And while 6P6C isn't exactly a common cable anymore as compared to Cat5 or Cat6, it's still cheap enough that you could purchase custom length cables if needed. Cables are included in the box with both the base unit and the extra sensor as well. And lastly is unneeded complexity. We only needed 4 pins to make the temperature sensors work with our brain units. We didn't need the 8 pins that are provided by an RJ45 jack. Next up, how many temperature probes can be connected to the Axe PoE, and can they be daisy-chained together if you need more? First off, the THP probes all support both temperature and humidity monitoring, and you can connect 2 probes to a single Axe PoE brain unit. A single temperature and humidity probe is included with the base unit for $149, and you can purchase a second temperature and humidity probe for $29. The Axe PoE cannot be expanded beyond the 2 sensors, but there's no reason you can't run multiple Axes on the same network. They are just Ethernet devices that respond to SNMP. Do we have any options for configuring multiple devices at once, or any remote management ability? At this time, no. Each Axe will need to be configured via a direct USB serial cable individually. We are exploring methods of updating and configuring them remotely, but we haven't committed to supporting that quite yet. Do we have any plans for other monitoring protocols like MQTT or Prometheus? We will explore adding both of those in future firmware releases, but we're not going to commit to it yet either, especially in the release version of the firmware. MQTT would be simple enough to add, I think, but adding support for Prometheus would require a web host as it relies on HTML queries, and that could potentially add an attack surface to the device. SNMP was our main focus for development as it's still the most widely used monitoring protocol. And finally, what's next for production? Now that we have all of our hardware bugs ironed out, it's time to start compliance testing for CE, UKCA, ROHS, and any other regulatory requirements for international sales. We've also got some other hoops to jump through, like making sure we have a block of MAC addresses and vendor IDs, writing up documentation and how-tos, as well as getting the firmware ready for an open source release. The pre-order campaign on Crowd Supply is open until next Thursday, May 15th, and if you're wanting to get in on the first round of production, I highly recommend heading over there and reserving your devices. If all goes well, we'll be shipping around the end of summer, and once all of our backers have received their devices, you'll be able to order devices directly from Crowd Supply and potentially some other retail partners that we'll announce at a later date. And one last time, thank you to everyone so much for your interest and your support in the project so far. I'm incredibly excited for you all to get your hands on our first retail product in the Openviro Axe PoE, and we should have some more news about future devices before the end of the year. This has all been a ton of work to make it this far, and I couldn't have done it without your support. If you have any other questions that I didn't answer about the Openviro Axe PoE, leave them in the comments below and I'll make sure to get you an answer. Or you can email me directly at info@openviro.com. You can also follow me on Blue Sky at openviro.com for news and updates, or check out our website at openviro.com. That's going to do it for me in this one. Thank you all so much for watching, and as always, I will see you in the next video. Cheers, everyone.